All right, welcome back to The Explainer. Today we're unpacking part 3 of our 4-part API and integration on GCP series. And since you're senior multi-cloud architects, you already know we're building up to some serious enterprise-grade architecture here. So today, we're putting a massive magnifying glass on one of the absolutely critical aspects of modern system design, architecting truly resilient, event-driven integrations right on Google Cloud Platform. Let's get right into it. So, I want you to picture the sheer terror of a massive traffic spike hitting your tightly coupled services. You know the drill, it's Black Friday or maybe a huge product launch. Marketing just pushed the biggest promo of the year, and traffic spikes like 10,000% in a matter of seconds. If you're still running a legacy monolith with synchronous connections, well, your database locks up, the payment gateway starts crawling, and that one initial surge just causes a total system collapse. It's literally the ultimate nightmare scenario for any architect, right?
To survive those kinds of spikes, we have to fundamentally shift our thinking. We need to move away from fragile synchronous dependencies and toward resilient asynchronous architectures. You want a system where a single point of failure doesn't just, take down the whole ship. Look at the stark contrast we've got here. On one side, synchronous systems require everything, and I mean everything, to work perfectly at the exact same time. If one link breaks, the whole chain snaps. But on the flip side, asynchronous systems are decoupled. They act almost like shock absorbers. So when that massive wave of traffic hits, the system just absorbs it, holds it, and processes it at a reliable speed without buckling under the pressure.
Here's our roadmap for building out that highly scalable solution today. We're going to hit the event-driven imperative, unpack the GCP integration toolkit, walk through a real-world order workflow example, tackle architecting for unavoidable failures, and wrap it all up with 4 essential event patterns.
All right, Section 1, the event-driven imperative. It's time to move beyond the bottleneck.
Look, as a multi-cloud architect, your job isn't just to build the happy path. You have to architect for disaster. And the hard truth? The most dangerous bottlenecks usually aren't even your own code. They're external dependencies. Think about it. If a vital third-party service drops offline, maybe it's a shipping rate calculator or an email provider, a tightly coupled system is going to cause the entire user experience to just grind to a halt. Your application literally just sits there, waiting for a response that is never coming, eating up resources until the whole thing crashes. It's a classic cascading failure, and it's exactly what an event-driven architecture prevents.
Moving on to Section 2. Let's look at the GCP integration toolkit. Basically, your heroes for scale. So let's introduce the specific tools that are going to cleanly separate their best use cases. First up, we've got PubSub. Now this is your heavy lifter. It handles massive scale fanout, which means a single event can be broadcast simultaneously to dozens of different microservices globally. Then there's EventArc. You're going to use this to manage complex SaaS integrations and handle sophisticated event routing natively within GCP. And finally, Cloud Tasks. This one gives us super precise asynchronous execution. You'll lean on Cloud Tasks when you need rate limiting to protect a legacy backend, or if you need a task executed at a very, very specific time in the future.
Okay, Section 3, the order workflow example. Let's trace the journey of an event.
To make all this theory concrete, let's track a single e-commerce order through a simulated system. Watch how one simple checkout event initiates a massive fanout, triggering inventory, payment, and shipping entirely asynchronously. None of these services are waiting around for the others. So, step 1, the user clicks buy, and a checkout event fires off instantly. Boom, the user screen immediately shows a success message. Step 2, PubSub picks up that event and triggers the inventory check. Meanwhile, step 3, concurrently, EventArc routes the data right over to your external payment processing SaaS provider. And step 4, Cloud Tasks steps in to handle shipping initiation, maybe even queuing it up to run later during optimal warehouse hours. It's just a beautifully orchestrated dance where absolutely no single service blocks another.
Which brings us to Section 4, architecting for unavoidable failures. Time to embrace the chaos.
But let's be real. What actually happens when that payment gateway times out or a message gets delivered twice in all this distributed chaos? Because network hiccups, they're a feature, not a bug. And at least once delivery guarantees essentially mean duplicate messages will happen. So the absolute crucial point here is idempotency. You have to guarantee that even if a charge payment message gets processed twice, the customer's credit card is only billed once. Idempotency is just that property of an operation where it can be applied multiple times without changing the result beyond that first application. You pull this off by assigning a unique transaction ID to the event and then always checking the system state before executing the action. Trust me, without this, your resilient system will rapidly turn into a total customer service nightmare.
And beyond duplicate messages, we really have to talk about changing data structures.
If you ignore schema evolution when your message formats inevitably change, you are for sure going to break downstream consumers and experience silent data loss. Picture this. You suddenly add a new discount code field to your checkout event. Well, if the downstream shipping service isn't programmed to expect that brand new schema, it's just going to drop the message entirely. You end up with processing bottlenecks and cascading system errors everywhere. Managing schema evolution, like using a registry, is quite literally just as important as the integration itself.
So, to handle those inevitable failures, the system automatically reroutes unprocessable messages to a retry loop and eventually into a dead letter topic so they don't clog up the pipeline. Let's say in step 1, the inventory service just goes completely offline. Instead of dropping the order, step 2 pushes that message into a retry queue using an exponential back-off strategy. Now, if the service is still dead after the maximum number of retries, step 3 routes it securely over to a dead letter topic. The broken message is parked safely for an engineer to review later, and the rest of the system happily just keeps right on processing healthy orders.
All right, final section, number 5, 4 essential event patterns. Let's build up your architect toolkit.
Now that we've survived the chaos, let's formalize these lessons into 4 overarching, event-driven patterns that you can literally apply to your integrations today. First up is event notification. This is just a simple, hey, something changed alert that prompts another service to look up the details. Next, we have event-carried state transfer, where the event actually holds all the necessary data so the consumer doesn't even need to make any follow-up queries. Then there's event sourcing, where every single change in state is logged as a sequence of events, which creates this perfect, replayable audit trail. And finally, CQRS, which separates your read and write operations entirely, allowing you to scale them completely independently for maximum performance.
I want to leave you with this final thought. Take a hard look at your architecture today and ask yourself if you are truly ready for the storm. What hidden, fragile dependencies are lurking in your current multi-cloud setup right now? If that massive Black Friday traffic spike hits tomorrow, will your system shatter or will it absorb the shock? By leveraging GCP's integration toolkit and these resilient event-driven patterns, you're not just engineering a system that survives the chaos, you're building one that thrives in it. Thanks for joining me on this explainer, and I really hope this helps you build something incredibly robust out there.